Alright, so I hope you guys are all done with the example, the class activity that was assigned, and we're briefly gonna go over this, and let's see what we can infer from this set of data, right? So first of all, we're gonna do inmate versus cell phone. So let's go straight to data analysis, regression, and we're choosing Y input data. Y input is from here to here. I'm sorry, Y is the number of inmates, so it should be this, right? Because we are looking at the number of people who are in jail depending on usage, cell phone usage, and the number of registered motorcycles, right? So that's our Y value, and for X value we are using this. So Y, this is the dependent variable, and here is the independent variable. Independent variable is a variable that we're looking at if this is causing anything from here. Okay, so that's that, and then we're gonna make another sheet. So question, no, let's just do inmate, no, sorry, so let's just do cell phone regression. Okay, so if we do that, we get all these values, and we are going to look at these here, right? So multiple R is the correlation, and this is very, very high, so it means that, oh, sorry again, I'm gonna zoom in. So this is saying that there is a strong positive linear relationship. Okay, and before doing anything, we have to look at R to see if it makes sense. And here we are very, very satisfied because why? R squared, right? R squared means what? How much data, how much variation in the data is explained by this model, right? So that's why we say we are very satisfied with this result, because 97.335% of variation in the data is explained by the model. Okay? And again, just to let you know, R squared means simply correlation squared. Okay, so if you square this number, you would get this number, right? So adjusted R square, we are not very concerned with that at the moment. And standard error, I wasn't going to talk about this, but this is the standard. I think it's better to have an idea of this. So standard deviation of the errors. So what it means is that we are looking at the variation of error. Okay, so if this value is lower, it is better. So whenever we have a standard deviation, it means it just means that we want to lower the value, because that's essentially what we're looking for. Okay, so that's taken care of, and this is the number of observations, and we are not concerned with all these numbers yet, but we are concerned with this, right? Intercept is this is B0 and this is B1. So okay, let me just write this down. Our final equation, y hat, this is y prediction, is equal to 1.11099 plus 0.00192 x with the hat. Okay, so this is the B0 and this is the B1. Alright, so that's taken care of. And let's look at the residual plot. Okay, hopefully we'll have a nice plot here. So it makes sense for us. Okay, so now what can we say about this? Um, well, for one thing at least, this is not completely random. If you see going up and down, there is a pattern going on here. So although we are very, very satisfied with r and r squared, right? If we're looking at the residual, but this is not very satisfying because there seems to be a pattern of going down, up and down, right? This may not be the case, but we see that it's right here. So we have to make sure to comment on that. So why don't we just do that now? So from this data, we can say that, so say this is a conclusion. Although we are very satisfied with our model in terms of correlation coefficient and r squared, the residual plot seems to have a pattern. Thus there might be a relationship that our model did not cover. Right? Something like this would be nice to have as a conclusion. So you can say that there's a pattern in the residual plot. So although we are satisfied with our model in terms of correlation coefficient and r square, still it's not perfect. It's very disappointing to see a pattern here. Okay, so that's how you would do it. Let's go back to question number 1. And then here, now we're making a prediction for x equals 1.6. Okay, so x equals 1.6. We have the formula here, the equation here, so we can just do 11099 plus 0.00192 times 1.6. And this is the value we get, 1.11. Right? So 1.11. If we're looking at here, x equals 1.11. Oh, oops. I made a mistake here. So it wasn't 1.11. So I'll fix it for your reference, but this is not x, right? This is not x. Instead, it should be, let me just make a number for this. Just say 170, right? So going back here, we can say that it wasn't 1.6, it was 170. And 1.437 is our prediction. So if you go to 1.7, well, this is, now I see a problem with this. This is inverted. So I'm sorry if I confused you. There is a problem with this because rolling column. Okay, so there is a problem with this because when we are doing the correlation, the x has to be on this side, right? So I'll make sure to fix that for um yeah, I'll make sure to fix that. Alright, so let me do that first. Okay, sorry about that. I'm gonna fix this up. I figured out a way to do this. So we're gonna go to right click, select data. Alright, so and it gives you a series where you can put in the legend entries, right? The legend entries, we're gonna edit this, should be the labels. So it's going to be inmates and cell phones, okay? These two that we're concerned with. And it asks for series X values. Right, on the X-axis, we're gonna have the cell phone, right? So we're gonna choose cell phone instead and enter, and for Y value, instead of having cell phones there, we're gonna have number of inmates. Okay, so that's how you switch X and Y. And then press OK and OK. And now this is a graph that you get from the previous editing. So these are the changes that we have made, and I just wanted to add the trend line and choose more options, and then we can also show the equation for this as well. So let's see. So display equation on chart. Alright, so now the equation is displayed. Alright. So using this equation, we can make a prediction for x equals 170. That's for cell phone versus inmate. So let's just change that as well. For let's see, more options, and then show. No, this is not working. More options and display equation on chart. Alright, so equation is displayed, and now we can look for the prediction x equals 170, right? So from here you can say 0.00019 times 170 plus 1.111, and this is the prediction that we get for x equals 170. And you can do the same for the second part, inmate versus motorcycle. And I'm gonna post up the answer key so you can refer back to it. So that ends our class discussion. But before we move on to our Q&A session, I do want to review again. Going back to our notes, right? Okay, so in this class we learned about linear regression, and I know it's a lot of information, but this is the end of the chapter, and we're moving pretty fast. I'm very satisfied with how we're doing, but we are at the end of chapter 3 right now, linear regression. We learned about correlation coefficient, and we also learned about linear regression, right? Fitting a straight line into a data set. So with that being said, I have a project for you, and let's go to, let me look for my project. Okay, so this is a project, and it seems like a lot of information, but it's compared to the other ones, it's not that much. So just to give you a little background of the project, if you go to the file here, you will see background, data, and questions, right? From background, you will get the background story of what's going on and what data sets you have and what they represent, right? All variables and all the stuff like that. And we also have the question of the study, right? So just to briefly introduce you to um, this project, what we're trying to do here is we're trying to match up the college examination score with college GPA. Alright? So SAT is a college examination that almost every high school students has to take in order to get into college. Right? We call that SAT, and I just gave you a brief introduction to it, so you can look through that. But for when deciding if the college is going to admit the student or not, the colleges, they're going to look at their grades, activities, if they had any awards, test scores, and so on and so forth. But we're looking at here, our study of focus is if the college GPA is related to the SAT score, meaning SAT score is the college examination score. So it people say that it's an indicator of how well they're going to do in college. So we're going to see if that is true. And obviously we're not going to have the population, so we just picked out a small sample, and these are 105 students who graduated State University with the BS in computer science. So these are computer science majors, and they have, if you look at the data here, so this is the high school GPA, and we have for college examination, SAT, we have math and verbal section. So these are math scores. All math and verbals are out of 800 points. So these are all the scores here, and verbal score, SAT scores, and this is the computer GPA, because these are computer science students. So these are their major GPA out of scale of 4.0, and same, this is the university GPA overall. So here the question asks, can the math and verbal SAT scores be used to predict college GPA? And the second part is, are the high school and college GPAs related? So this is the main question that you have to answer. And I laid out all the detailed questions. So you have to draw a scatter plot, correlation, and the regression and everything. You have to make some predictions as well. So you are going to do all this. This is the project, and this will be due on Monday. Right? So you can start working on it, and if you have any questions, just let me know tomorrow. I do want you to look over these. So before you get into any trouble, you can just ask me, and I'll help you out with that. So this is the first assignment. And lastly, I want you to come up with the conclusion, right? So I mean, for class like this, we are never going to have a very, very conclusive conclusion. I mean, that sounds a little weird, because conclusion is supposed to summarize everything, and you're supposed to give them what your findings are, but you have to also talk about your errors, or if there are any problems with your model, right? So here we're going to do the linear regression. So you are definitely going to use a model, and you have to make a comment on them. Like if there were any patterns in your residual plots, or if if there might be another, like, better model that can be suited, or if there is any bias. Okay, so those are um, all included as part of your conclusion. So this is your class project, the very first one. So I want you to work on it, and if we um, I gave about 30 minutes for the class activity time, but if you guys are if you guys have extra time, I want you to look at the project right now before we have the Q&A session. All right? So um, that's that, and I will see you pretty soon in the Q&A session. Okay.